What if everything we see in the night sky is just a fraction of reality? Astronomers now believe Earth may be trapped inside a massive, invisible cosmic void, one so vast and strange it could reshape everything we know about the universe, or all across the solar system. This is where the gravitational influence of multiple objects will move into this step pattern with each other. You get an orbital resonance of the moons of Jupiter where Io, Europa, and Ganymede are in this orbital resonance. And there are examples of 1-2 orbital resonance. There are examples of even 1-1 orbital resonance. And now astronomers have found a couple of objects that are in an orbital resonance with Uranus. The main object is called 2015U194, and it's a centaur, and these are a class of objects that are kind of like a rocky asteroid, and kind of like a comet, and they orbit in between Jupiter and Uranus. This object is in a 3-4 resonance with Uranus, and that means that it completes 3 orbits around the Sun for every time that Uranus completes 4 orbits. And it's very stable. U194 has probably been in this resonance with Uranus for 1,000,000 years and will probably remain in resonance for another 1,000,000 years from now. And the astronomers who found this found a couple of other objects that seem to have a very similar orbital resonance. And we've got a story about this from Mark Thompson. So let's go clues of an ancient stellar flyby farther out into the outer solar system. Once you get out to the Pluto area, you're in the trans-Neptunian objects, and these orbit the Sun out beyond the orbit of Neptune. Pluto obviously is the largest one of this, but Aries, there's a lot of other objects in this area, and that's why Pluto is in the planet they say, because it hasn't cleared out this region. Many of these objects follow an eccentric orbit around the plane of the ecliptic. But there's also a bunch of objects that are off of this region called the scattered disk. And astronomers have been looking for an explanation for how you would get this spray of materials that are so far away from the plane of the ecliptic. And there have been plenty of theories that have been proposed perhaps when Uranus and Neptune were moving out, and they switched places as part of the early solar system formation, that the gravitational influence of those two objects might have scattered objects away. But a new paper has come out where astronomers wondered, could a stellar flyby cause the same effect? And they were looking specifically is how close would a star have to get to be able to mimic what we see. They simulated a star with about 80% the mass of the Sun coming within a couple of hundred astronomical units of the Sun. And then they found that once you're about between 110 and 150 astronomical units, then you got this scattering effect. And we've got a story about this from Evan Goff. I promised that we would be oldest comet in history reporting on the newly discovered Comet 3 Atlas, the third interstellar comet. And we've got a new really interesting piece of information that suggests that it is probably the oldest comet that we have ever seen. Now, all of the comets in the solar system formed with the Sun, and so they are all about 412 billion years old. But Comet 3 has come from outside the solar system. Now, it could have come from a star system that is younger than the Sun. It could have come from a star system that is older than the Sun. And now astronomers looked at the region that the comet came from. Now, we can't know which star that it actually came from, but we can look at its orbit and know the general region of the Milky Way that it did come from. And there's sort of two parts to this. One is the thin inner disk, and this is where the Sun comes from. And you've got these third-generation stars. They're relatively younger. And then you have this outer thick disk of the Milky Way. And this is filled with older stars that could be as old as the Milky Way itself. And it looks like Comet 3 came from this outer thick disk. And the astronomers estimate that it probably is about 2 to 3 billion years older than the solar system. It could be as much as 7.5 billion years old, which definitely makes it the oldest comet that we have ever seen. And we've got a story about that by David Dickens. Now, sunspots, let's talk about the Sun. And it doesn't take much to see a sunspot on the surface of the Sun. Now, I need to reiterate, never look at the Sun without any kind of eye protection. But if you do have a telescope or binoculars and you have proper solar filters, then you can see sunspots on the surface of the Sun. If you don't have that, then you can do a projection where you can actually magnify a version of the Sun onto a piece of paper, and you can see these sunspots on the surface of the Sun. And these are very long-lived. They can last for hours or even days, or even months. And this is very surprising because the surface of the Sun is this rowing boiling plasma, and you would expect that these features wouldn't last for very long. Astronomers in Germany have built a telescope that allows them to resolve the polarization of the gas on the surface of the Sun almost as good as if they had a space telescope. And the polarization essentially corresponds to the magnetic fields that are going on the surface of the Sun. So astronomers were able to see the magnetic fields in the sunspots, and what they could see is that the magnetic forces appear to be perfectly balanced by the pressure forces that are coming from outside the sunspot, and this keeps them stable for much longer than you would expect. We've got a story about that by Mark Thompson. Every week, we do vote results of vote on our channel where you tell us what you thought was the best space news story of the week. And the winner this week was a rogue planet hiding in Hubble data. So, thank you everybody who voted. Now, we will post the new vote here on the channel. So, if you're watching this video, it's there right now on the post tab. Just go in there and unvote. Tell us what you thought was the best space news story of the week. Of course, if you want to see these votes, make sure you're subscribed to the channel, click on the notifications bell, and then just vote anytime anyone ever asks you to vote, and that will train the algorithm. Here's a classic question. Source of Earth's water, where did the Earth's water come from? And here's the problem with having water on Earth. And that problem is the Sun. The Sun is putting out intense radiation. And if you've got water that is closer than the frost line in the solar system, it's a region in the asteroid belt, about halfway through the asteroid belt, that if you're farther away than the frost line, then there isn't enough radiation that is heating up the ice and causing it to sublimate. And so you can have objects with ice. And that's why you can have icy moons around Jupiter and Saturn. And you can even have icy objects in the asteroid belt. But if you're closer than this frost line, then the temperatures are too high. The radiation from the Sun melts any ice, and you have dry rock. And that's why we don't see polar caps on the Moon or on Mercury except for in the southern craters. But anyway. And so the question is, why does Earth have so much water? It should have all evaporated early on in the history of the planet. And so the explanation has always been that some process delivered the water later on. Maybe it was from comets, maybe it was from asteroids, maybe it was from a combination of both. But according to a new paper, this idea of the frost line is something that needs to be reevaluated because it's not this very specific line in the solar system. It's more like a zone, and it could very well be several astronomical units wide. It all depends on the size of the objects that are covered in water. And so if you do have this more diffuse idea of the frost line, then as the Earth was forming, it could be plowing through particles that still have water ice mixed in with them. And so it could have been gathering up its water, and no later delivery method would have been required. It all happened at the formation of the Earth. And we've got a story about that from Evan Goof. Dust. Dew is dust. It's a nuisance to us here on Earth, and it's a nuisance to astronomers because it obscures their view of the objects that they're trying to look at it. So apart from being an annoyance, this stuff is also scientifically interesting. Where does it come from? And there have been a lot of ideas that there are supernova could be dust factories, that supermassive black holes could be dust factories, and one new addition to this seems to be a very specific type of star called a Wolf-Rayet star. And I want to show you a picture of a very famous Wolf-Rayet star which will explain a lot of what we're talking about here. This is WR140. This is a picture taken by James Webb. And you see this incredible spiral pattern, and this is caused by the interaction between a Wolf-Rayet star and its partner star. Wolf-Rayet stars can be 30,000 to 200,000 Kelvin on their surface. Compare that to the Sun, which is just less than 6,000 Kelvin on its surface. These things are hot. They are massive, and they are putting out millions of times more radiation than the Sun does, and they generate very powerful solar winds. And so the solar winds will drive away from the Wolf star, but can collide with companion star stellar winds. And when they do, the material in these solar winds, which have higher amounts of heavier elements like carbon, will then condense and produce dust. And then that dust is then driven outward from this star and can remain in the cosmos for long periods of time. And so it appears that these Wolf-Rayet stars are dust factories and could be responsible for a lot of the dust that we see in the cosmos. We've got a story about that from Evan Goof. All portrait of a galaxy cluster right. We're near the end of the episode, so it's time for some images. And first up, this is an image of the galaxy cluster Abell 209, and it contains over 100 galaxies, and then all of the dark matter and all of their satellite galaxies. And so this is a gravitational lensing feast. And you can just look at the picture and see arcs. And these are from the galaxies that are being lensed by the foreground galaxy cluster. And you've got all of these stars separated by millions of light years. And that there is all of this hot diffused gas that is all mixed in with it, as well as other spiral galaxies in the image that have nothing to do with the galaxy cluster. It's a beautiful picture. We've got a story about that from Matt Williams. And then this is closest pic of the solar atmosphere crazy. This is the closest picture ever taken of the sun's atmosphere. This was taken by the Parker Solar Probe on December 25, 2024, when it came within just 6.1 million kilometers of the surface of the sun. Now, Parker doesn't have a camera pointed at the sun, which would have been awesome, but instead it has an instrument called the Wide Field Imager for Solar Probe. It's called Whisper, and it looks a little off to the side. It has 2 cameras, and it was able to take these pictures of the solar wind being generated off of the surface through interactions on the corona. And you can see this time lapse of the solar wind coming off of the sun. Absolutely incredible picture. If you want to learn the science, we've got a story by Evang. And can you believe it? James Webb has JWST 3rd anniversary now been operating for 3 years. It had its anniversary on July the 11th, 2025. And to celebrate the anniversary, the people behind the telescope released this image of the Cat's Paw Nebula. This is a star-forming nebula. Astronomers have already found about 700,000 stars in this nebula, as well as thousands of times the mass of the sun in dust. It's about 5,500 light-years away from us and spans about 320 light-years across. And so it's an emission nebula where the hot radiation from all of these stars are heating up the surrounding gas and causing it to glow. But under the eye of James Webb, it can see through that gas and dust and reveal all of the stars that are hidden inside of it. It's a beautiful picture, a very worthy 30-year anniversary for James Webb. And we've got a story about that from Evan Goof. Guide to Space Now. Are you still hungry for some more space news? Because I am currently writing my weekly email newsletter that contains another 30 to 40 space news stories. Everything we're covering over at Universe Today. For example, how an ancient moon rock revealed a missing chapter in the history of the moon. Story by Mark Thompson. A strange binary system where one hosts a giant planet while the other has a protoplanetary disk. We got a story about that from Evan Goof. And then a really cool story about how the United Kingdom is considering its own mission to Venus to search for life. And we've got a story about that from Mark Thompson. Now, I write my newsletter every Friday. It goes out to 72,000 of my closest friends. It's completely free. There's no ads. Go to universityertoday.com/newsletter-spacebites to sign up. Now, we've got a longer version of this exact video over on Patreon, and it has one additional story. We call that Spacebites Plus. And this one is very cool. This is about how astronauts could build a dome of lunar concrete over a crater on the moon, and then pressurize it and turn it into a habitat to be able to live in. So, I'm going to put a link in the show notes so you can go over and watch that version over on Patreon. And just to be clear, this is not a paywall. You can watch this completely for free and you actually don't get any ads over on Patreon. It's completely free. There's no ads. More content, go watch it over What's the Deal with Patreon there. I'm going to explain a little bit more about what material we put over on Patreon and why it's still free. But first, I'd like to thank our patrons. Thanks to Abe Kinson, Andrew Gross, Bay Lake Roofing, Brian Bod, Caradwin, Chuck Hawkins, Commander Block, Sign Nelson, David Gilson, David Mass, Dustin Cable, Evan Pro, Greg Phy, Hudson Ward, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Marcel Smiths, Michael Purcell, Monzo, Paul Robb, Rin Kaidu, Robeck, Sean Sargent, Stephen Fair, Miley, Vlad Chiplin, and Wolfgang Claus who support us at the Master of the Universe level and all our patrons. All your support means the universe to us. Now, I talk about this every week, how we have put a version of every single one of our episodes over on Patreon, and we make it longer. So, we have the Space Bites Plus, we have the Interviews Plus, and we have the Q&A Plus. And with each one of these, there's one additional piece of content. So here on Space Bites, you watch the story here, but there's one more piece over on Patreon. There's an additional chunk in the interviews. Hit that subscribe button, share your thoughts below, and let's keep exploring the together. Thanks for watching, and we'll see you in the next.